Hi, this is Mrs. Villette, and I'm going to record a video about matrices. The reason we're going to talk about matrices right now is that there's actually a way that we can use our calculator to solve a system of equation using matrices. So the plural is matrices, but just one of them is called a matrix. And so what is a matrix? A matrix is simply just a collection of numbers in a rectangular arrangement, sometimes called an array. So for example, we could have a matrix with the numbers 1, 2, 0, 4. And what you'll notice is that this particular matrix has 2 rows and 2 columns. So we have what's called a 2 by 2 matrix. Let's look at another matrix. Let's say we have the matrix 1, 2, 3, -1, 4, 7. This matrix also has 2 rows and 3 columns. We would call this a 2 by 3 matrix, but we usually actually write that a little bit differently. Instead of the word by, we use a multiplication symbol, so a 2 by 3 matrix. We could, of course, also have a matrix, let's say 1, 0, 0, 1, 3, 4, that has 3 rows and 2 columns, so this would be a 3 by 2 matrix. Now, if you're ever having a hard time remembering which number comes first, just remember RC cola. If you look in RC cola, rows and then the columns are what come in RC cola. So rows first and then columns. So we've already discussed that we're going to use matrices as a way to solve systems of equations. Let's just discuss quickly another way that you could use a matrix. Matrices are just useful for storing information. You could, for example, have a group of 4 children. So let's say you had Avery, Jack, Colin, Hadley. And those all have unique initials. So let's take a look at putting Avery, Jack, Colin, and Hadley in the columns and then also in the rows. We could use numbers, in particular zeros and ones, to represent who's friends with whose. So by default, we're going to say everybody kind of likes themselves. So along the diagonals, we're going to enter ones. So Avery likes himself, Jack likes himself, Colin likes himself, Hadley likes herself. I guess Avery could be a girl or a boy, doesn't matter. Now we're going to put zeros if they're not friends. So let's say that Avery is friends with Colin and Hadley, but not Jack. Okay, now, but let's pretend that Jack doesn't know that Avery doesn't like him or her. And so Jack, he says, well, I'm friends with Avery. And I'm friends with Hadley, but I'm not friends with Colin. And then let's say Colin also doesn't really like Jack so much. Colin doesn't like Avery so much. In fact, Colin doesn't like anybody except himself. And then Hadley just likes everybody. So we've used a matrix just to describe the relationships between people, whether they like the other person or not. If you take a course in college called linear algebra, you can learn some really interesting things you can do when you multiply these matrices together. So it's a really interesting topic, but we're going to focus just on systems of equations. But before we do that, we need to know how to do some basic arithmetic on matrices. So let's talk about how we would add matrices. Let's concentrate on a simple case, 2 by 2 matrices. So 1, 1, 0, 4. Let's say I want to add that to 2, 4, -1, 7. Well, it adds the way that you would expect it to add. This is going to be a 2 by 2 matrix, and I'm just going to simply add the corresponding rows and columns. So I'm going to add the first row, first column entry. It's 1 plus 1, so this number plus this number to give me 3. I'm going to add the first row, second column, then second row, first column, and second row, second column entries together. So that's how you add matrices. Okay, before we talk about multiplying, we need to know what's called the identity matrix. So the identity matrix is a square matrix. So it's n by n, and it has ones along the main diagonal, and the main diagonal starts at the top left and goes to the bottom right, and then zeros elsewhere. For example, the 2 by 2 identity matrix would go 1 along the main diagonals, 0 everywhere else. The 3 by 3 identity matrix, same idea, 1's along the main diagonal, 0's everywhere else. Okay, we want to talk about multiplying matrices, and matrices don't multiply the way that you would think that they would. So you don't just simply multiply corresponding rows and columns. What you do in a matrix is you multiply a row by a transpose of another column. So what do I mean by that? Well, let's say I had a 2 by 2 matrix, and I wanted to multiply that with another 2 by 2 matrix. Now, it's not even clear that we can do that yet, but we'll go ahead and see what it looks like. Okay, so what we're going to do to multiply these two matrices is I'm going to look at this row, this first row, and I'm going to look at the first column, and I'm going to multiply them together by transposing that second column. So what that actually means is I'm taking the 1 and I'm multiplying it with the 0, and then I'm taking the 2 and I'm multiplying it with the 2. And that is what's going to go into the first row and first column of my answer. So 1 multiplied with 0 is 0 plus 2 times 2. I didn't make that clear. We're multiplying and then we're adding. So 1 times 0 is 0 plus 2 times 2 is 4. Okay, then we're going to take that same first row and we're going to do the same thing with the second column. So now I'm going to do 1 multiplied with 1 and 2 multiplied with 3 and add those together. 1 times 1 plus 2 times 3. So 1 plus 6 is 7. All right, now we move on to the second row, and we're going to multiply it by the first column, and we're going to multiply and add. So 3 times 0, which is 0, plus 7 times 2, which is 14. And then we're doing that first row, second column. 3 times 1 is 3, plus 7 times 3. So 3 plus 21 is 24. So that's how you multiply matrices. We really just need to know how this is going to work for a system of equations. So let's take a look at that. Normally, I could have a system of equations like 2x minus 3y equals 2, 4x plus y equals 7. And I want to represent this in a matrix. So the first way I could do this is using a matrix equation where I just put the left-hand side, which is in standard form, as the first row and second row. So I put the first equation on the first row, the second equation on the second row, and then I put the constants over here on the right. This is called a column matrix here because it just consists of a single column. Now what I really want to do is I want to separate out the x's and the y's so that I'm just writing the coefficients. So it turns out that I can just write the coefficients, 2, -3, 4, 1, and say that I'm multiplying that by the matrix x, y. And that still equals 2, 7. Now we can see that if I take this first row and multiply it by this column, term by term I get 2x, subtract 3y as the entry in the first one, and then I would do the second row multiplied by that same column, and I would get 4x plus 1y, or plus y. So it's the same thing. So what we're really doing here is we're just teasing out the variables from the coefficients. So let's take a look at that again. And again, this was equal to 2, 7. So teasing it back apart, we get the coefficient matrix 2, negative 3, 4, 1, multiplied by the column vector xy equals 2, 7. Now we're going to call this coefficient matrix the matrix A, capital A. We use capital letters for matrices. I'm going to call this column matrix capital X. We're going to call it capital X even though it has x's and y's because we want this to work with any dimension of system. So we want to work when we have x, y, z, or even 4 or 5 or 6 variables, in which case we'll just call them x sub 1, x sub 2, x sub 3, etc. So we have said this is the same thing as saying A times x equals, and we will call this matrix over here capital B. What we're trying to do in a system of equations is we're trying to solve for this matrix X. So this column matrix X is what we want. Now this looks very similar to a linear equation, where typically if I wanted to solve for x, I would divide both sides by capital A. However, we do not have a defined way of dividing by a matrix. What we do have, however, is an inverse matrix. So let's take a look at this equation that we've written. We've written this equation, A times x equals B, where we keep in mind that the A, the x, and the B are all matrices. I want to get the x by itself. So instead of dividing both sides by A, because I don't have a way of doing that, I'm going to multiply on the left by a matrix called A inverse. And I need to make sure that I'm multiplying on the left because matrix multiplication is not commutative. What happens when you multiply a matrix by its inverse is you get what's called the identity matrix. And we talked about the identity matrix. The identity matrix is the matrix that has 1s on the main diagonal and 0s on the off diagonal. So remember, in this case, we were talking about a 2 by 2 matrix. So that's my 2 by 2 matrix multiplied by the matrix xy equals this matrix A inverse times B. If I examine this left-hand side a little bit more, though, and I do the matrix multiplication, I have 1, 0 multiplied by xy. 1 times x plus 0 times y. So I just have x. And then I do 0, 1 multiplied with xy. 0 times x plus 1y, I just get y. When you multiply the identity matrix by any matrix, you simply get that matrix back. So the identity matrix is like the number 1 in our real numbers. It is the multiplicative identity, meaning it does not change the value of whatever you're multiplying it by. So xy equals A inverse times B. Remember, x and y are the values that we're trying to find. They're the values of the variable. So if we have a way of calculating this A inverse and multiplying it by B, we can actually get our answer. Luckily, we're not going to make you do that by hand. Your calculator will actually calculate the A inverse. You just have to tell it what A is and tell it what B is, and it will do it all for you. And I will provide you a link to a YouTube video and a document showing you how to do that. Now this will work for a 2 by 2 matrix, a 3 by 3 matrix, 4 by 4. In fact, any n by n matrix will work.